Welcome to This Explainer. Okay, be honest. Have you ever looked at the back of your computer, or maybe the side of your laptop, and just felt totally overwhelmed by the sheer number of different ports? Well, today, we're going to completely demystify that entire alphabet soup of cables and connections. In this fast-paced explainer, we'll trace the evolution of these technologies, break down their hidden capabilities, and show you exactly how the hardware sitting on your desk actually works. Okay, let's dive into this roadmap. We're going to tear through the universal serial bus, unpack USB power and pinouts, shift gears to the display ports, explore the sheer power of Thunderbolt, and then wrap the whole thing up with wired networking. Section 1. The Universal Serial Bus. It's time to introduce the undisputed king of connectivity, tracing its incredible evolution from those single-purpose legacy rectangles to modern digital supremacy. Let's kick things off with USB-A. You know the one. It's the classic elongated rectangular port you see on pretty much every laptop, desktop, and TV out there. It's been the ubiquitous standard for years, keeping our keyboards, mice, and all those basic accessories connected. But as incredibly compatible as it is, its biggest physical flaw is that it's just not reversible, which, usually means trying to plug it in 3 times before you finally get it right.
And this brilliantly illustrates the massive leap forward. Just contrast the directional 4-pin design of USB-A with USB-C. USB-C is the modern standard, and it's a real game changer. It's fully reversible, meaning there's literally no wrong way to plug it in. Plus, it acts as this massive pipeline, handling high-speed data, huge amounts of power delivery, and even video output, all at the exact same time through one single cable.
Now, what's really interesting here is the number 10,000. You might think these tiny little connectors are delicate, right? But modern micro-USB and USB-C connectors are meticulously engineered and rated for a staggering 10,000 insertion and removal cycles. To pull off that level of durability, engineers actually took the leaf spring mechanism out of the jack and moved it to the plug. That ensures the most stressed part is on the much easier to replace cable side rather than buried deep inside your expensive laptop or phone.
Let's move chronologically and see how this builds, because the leaps in data transfer speeds over the decades are just staggering. Back in 1996, USB 1.0 crept along at a tiny 1.5 megabits per second. By 2000, USB 2.0 gave us high speed at 480 megabits. Then in 2008, USB 3.0 brought superspeed, adding dedicated lanes for 5 gigabits per second. Once the USB-C spec was finalized in 2014, the architecture basically blew the doors off the industry. By the time we hit modern USB 4 specs, we're scaling up to a blistering 120 gigabits per second in a single direction.
Section 2. USB power and pinouts.
All right, we're going to transition rapidly from those insane data speeds right into the dense technical reality of electrical power delivery. What you're looking at is the legacy 4-pin design of standard USB. You've got your V-bus for 5-volt power, your ground, and your 2 data pins sitting right there in the center. But what's absolutely brilliant about this physical design is that the outer power and ground pins are actually positioned to connect first. Because the data pins are slightly recessed, power and grounding are safely established before the data conductors ever make contact. That's exactly what protects your devices during hot swapping.
But to reach modern performance, that rigid 4-pin limit just had to go. USB-C utilizes a highly dense 24-pin double-sided connector. By throwing out the old rules, USB-C unlocks multiple dedicated pairs for super-speed data transmission, a specific configuration channel to detect cable orientation, and biphase mark code configuration. Honestly, it's this incredibly dense 24-pin architecture that makes USB-C such an absolute data firehose.
So the crucial point is right here in the math. Just look at this jaw-dropping leap in power delivery. USB 2.0 delivered a mere 2.5 watts, barely enough to power a basic mouse. As standards evolved through battery charging 1.2 and into modern power delivery, we saw watts literally jump to 100. And now, with Power Delivery 3.1 extended power range, USB can negotiate voltages up to roughly 50 volts to push an incredible 240 watts. That is more than enough to power and charge a high-end, heavy workload laptop over just one single USB cable. It's wild.
Section 3. The display ports. Now we're shifting this explainer's focus completely away from raw data and power, straight into the visual realm of monitors and displays. And we really can't talk about displays without briefly paying respect to VGA, or Video Graphics Array. You almost certainly recognize this by its chunky blue multi-pin connector. VGA is the analog ancestor that transmitted, you guessed it, analog video signals. Because of that, the image quality was naturally a bit softer, but it completely paved the way for the razor-sharp digital connections we completely rely on today.
Fast forward to today, and it is essentially a two-horse race in the digital display world, HDMI versus DisplayPort. HDMI is the everyday consumer standard. Because it easily carries high-quality digital video and audio over a single cable, it's practically perfect for your living room TV or a basic home projector. On the flip side, DisplayPort is the professional standard. Hardcore PC gamers and video editors demand DisplayPort because it supports much higher refresh rates, massive resolutions, and a really cool feature called daisy chaining, which actually lets you link multiple monitors together sequentially from just a single port on your computer.
Section 4. The power of Thunderbolt.
Okay, gear up because we're moving to the ultimate hybrid standard that takes everything we've just talked about and mashes it into one absolute powerhouse. Thunderbolt acts as a supercharged multitasker for high-end professional setups. Physically speaking, it uses the exact identical reversible design as USB-C, so on the outside, it looks the same. But the protocol technology hidden inside allows it to transfer massive amounts of data at ultra-high speeds, simultaneously connect and drive multiple high-res displays, and deliver high-wattage power. It is literally so fast that it unlocks the ability to plug an external graphics processing unit, a full GPU, directly into a super-thin, lightweight laptop.
Section 5. Wired networking.
For our final category, we're going to pivot to the physical cables that serve as the actual backbone of the internet and our local networks. Now, you might be wondering, with Wi-Fi being as fast and convenient as it is today, why do we still care about physical networking ports? Well, power users still fiercely demand hardwired connections because they are significantly faster and vastly more stable. If you're doing competitive gaming or running a heavy stream, a hardwired connection delivers the absolute lowest possible latency and totally bypasses the signal interference that usually plagues local wireless networks. All right, I've got a technical surprise for you here, and honestly, this totally blew my mind when I first learned it. The networking port you've likely been calling RJ45 your entire life, it's actually misnamed. The plug we all use for Ethernet is technically an 8-position 8-contact or 8P8C non-keyed modular plug. True RJ45 is an obsolete telecommunications standard that used a mechanically keyed plug with an extra little tab to prevent it from fitting into regular Ethernet ports. But as things go, the RJ45 name just permanently stuck in our everyday language. If we look back at the origins of these registered jacks, we can completely geek out over the intense wiring schemes. This is the even count color code used in legacy RJ21 telecommunications. It's basically a giant puzzle. By systematically mixing a primary color like blue, orange, or green with a secondary color stripe, network engineers could flawlessly organize up to 25 pairs. That's 50 separate pins inside a single massive connector, all mapped out just by following the color math. It is seriously amazing how far the engineering has come. I mean, we went from clunky 50-pin telecommunications arrays to a single sleek USB-C cable pushing 240 watts of power and 120 gigabits of data. But wrapping up, it leaves us with a pretty provocative final thought. As all these standards converge into universally capable ports like USB-C and Thunderbolt, do you think we'll eventually see a totally portless future where absolutely everything is wireless? Or are we permanently trapped in the dongle era, forever adapting old legacy cables to our shiny new machines? Thank you so much for hanging out with us for this deep dive explainer. Keep questioning the tech around you.